Okay, here's the soft take. I'm gonna sketch it out, and then I might record a real one. If it goes well, or if this goes really well, I'll use it. I don't have my glasses. All right. Clean the old eyeballs. So, as you can see, we're going to try to do iterators. And the reason we can even try that is because I made abilities generic. So, abilities can now accept type parameters, and they can accept type parameters of two kinds. The first kind live on the ability itself, for lack of a better term, and are typically going to be used as input types. So if we had an ability to, like to string, not to string, but to of string, ability to anything, to of t, okay? This t, it basically indexes into the ability. Really, I have as many abilities as I want to talk about t's. So I have to string, and I have to int, and I have to buffer, right? And you could think of it as you could think of it as desugaring to there are four abilities, to string, to int, and to buffer, right? So that's the first type of type parameter. That's what I call an ability parameter. And it's the same as if you were to parameterize a trait in Rust. Now, the second type of type parameter I added are what I'm calling implementation parameters. These are types that are provided by the implementation. This is really important because the last thing you want for an output parameter is at the call site, every time I call next on an iterator, the compiler to be like, well, which type do you want? Like when you call next on this thing, like there are many implementations of iterator on this thing. So which output type do you want? So the intuition here is that for output types, typically, it's not strictly input output, but that's a good rule of thumb. You want to define the parameter as coming from the implementation. The classic example is Iterator, actually, where if we have an iterator over a thing, we really want the iterator to decide what type next returns, not the caller. The caller to decide what next returns would do so by either like threading through an expected type in the context or by explicitly providing. And this is why from and into can be awkward because I believe the trait from uses an associated type. No, it might be into. Anyway, maybe from and into aren't as good of an example. But here's our classic example with iterator. Yep. It's not the best way to explain it. Need a really good motivating example. Okay, but this returns I. Okay. So whatever the implementation decides, yeah, no. So impl iterable for list, and we're gonna have to do a concrete type because they didn't do that part yet. Shit. Okay, that's fine. And then iterable I equals, and I'm going to call it list iterator. Int. And I decide what I return. So, I mean, this returns an I. Well, yeah. And that's just going to be the actual struct. So let's just imagine we have list iterator. New. And for now, gosh, let's just pass in the list. And then that'll be it. T L is a list of T, and I'll give you list iterator of T, def type. Pause L. I have no idea if that's how you actually want to do an iterator. And then this is just going to be and pause is 0. Okay. Provide a type list iterator I64 for I does not implement required ability iterator. This is true. And we're going to get to that part. And now it does. Look at that. Look how fast. Pop. Pop. Okay. So this is compiling. So let's make one. Okay. That's not bad. So what I have here, oh, I don't have trade objects either. So this is such a hard use case. This is like the very final boss. Because what this is going to return, yeah, I'm just going to have a list iterator. I don't have a way of saying, hey, I just have something that implements iterator of T's. So, right, what I can't do is like the Rust. You get what I mean. It's fine. Let's implement next though. And then we're going to do we're going to call it item. It'll be an optional item. So this takes yeah, so on a given thing like this, I only want one implementation of iterator on it. So it's going to be an impl-side item. And now you missing implementation side parameter for ability iterator item. Oh, right. Int. Missing implementation for function next. Thought you'd say that. So really, it's an int. In this, I can say self, or I can say, oh, that should definitely be a compile error. Let's make sure. List iterator. For item. Doesn't implement required ability iterator. because iterable says that it has to implement iterator. And we do implement iterator for list iterator int. And we're saying that I needs to implement an iterable. It'd be easier to do all the iterators than all the iterables together. List iterator should be the least interesting thing. So we'll put it down there. List iterator of I64 does not implement iterator. But it does. So we have a bug. So I think either we're creating multiple copies of list iterator int, and then when we go to look up the implementation, we're using a new ID, or we're creating a copy of iterator I think we're probably specializing iterator, even though there should only be one because it only has impl parameters. So if I remove impl item, which is going to mess everything up, but if I just were to hard code it to int, now I get further. Function is missing implementation. Why do I not get that far here? Function is missing implementation. We don't get that far. We don't get that far because of probably the other bug. I don't know. We have L and pause. So switch L get itself dot pause none. Oh. Uh-oh. I need a pointer to self. I think that's okay. Woo! So I do a referencing, access, and pointer storage like that. And then we return some I. It's not start out, is it? Not like this. Oh, it sure is. So it needs self by reference. It needs self mutably. I'm okay with that. Oh, and it works. Yeah. List iterator for I doesn't implement iterator. Oh, shit. Okay. We got further, right? When I removed this, we just said in everywhere. Impossible pattern. You didn't get an I-64? Oh. Get. Does not return an option. I don't like doing this here. Self.pause if it's 3 and the length is 3. Pause. Self-top. Okay, let's say 0. It has to be less than. Method len does not exist. It's a field. Yeah. Needs to be a pointer, and it works. Gonna invoke print it with T option of I-64. We'll show for opt. Show. If self sum I dot show. Sum else none. Oh my god. I don't know. One, one, one. Yeah, you think there's something wrong? Okay. Could not infer enum type from context. Try supplying the name. We just use the helper function sum instead. Value assignment destination must be a variable, but I can write to a pointer like so. 1, 2, 3, none. Okay. This isn't too bad. Let's go fix that bug then. Okay. Switching to compiler land. So in the type checker, we have evaluate ability expression. Ability expression. Okay, well, I think I may need to pull up the code. So we have an ability expression is this thing. It's the name of an ability plus its type arguments. It's an expression in the type space, but it's not a type expression like in the language. In the language, like self star is a type expression. This exists in its own space. It's its own grammar, kind of like patterns, where we just say, hey, it's an ability expression. And it looks like a type expression because these things are all types. But an ability is not really a type. It's a thing that talks about types. It's its own thing. All right. This is an ability expression, right? So hang on. 30 W greater. No. Make it smaller. All right. God forbid I use my mouse. Let's do this. So there may be a bug here. I'm not sure how much of this I can narrate, but what's happening here is I think I need to short circuit if the spec.arguments equal the arguments. And yeah, so this is my case for do nothing. That so I do nothing if the ability doesn't take any parameters, like say show. I don't make a new copy of the ability that's specialized on those parameters because there are none. And if there are actual ability parameters, like well, nothing in our example has them. It's like for 2, like 2 on strings, then we check if they're all the same. But I don't have a case for there are parameters, but all they are ability parameters. So I think it could be as simple as let impl only, and then we can clean this up if the theory works. Would be arguments is empty and the ability kind. So, but still the case that the ability kind. So, and let me just println that doing a specialize on impl only ability, self name of ability name. Yeah, you're like this. So that's not very nice. And of course, if impl only. And we'll try this. And we should get, let's run. I want to run this thing. I can't use the LSP for this. Well, I could. I just want to see the output. Doing a specialize on impl only ability iterable. Yeah. And this is as I feared. So what will happen here is we won't find a specialization because we don't store a specialization. What I could do is actually just store one. So for an ability that's generic over on the impl side, I could just store itself with no arguments. Like, hey, if you specialize me on an empty vec, then you just get back me. But I think we can do a little bit better here. I think it's better just to detect the case. So an ability has only impl parameters, then ooh, not as generic, but actually the better thing to check would be ability.parameters all. Sorry. Okay. And then what I'll do is I'm actually going to assert. We should never get here. Can I do a function? If impl only. All right, debug assert. I'll use my De Morgan's. I'll use my logical powers. Not impl only or ability. For impl only, then arguments should be empty. Ooh, I'm getting really bad frame rate lag. I might need to not use the GUI version of pouring some more tea of NeoVim for these videos. Return okay. It needs no specialization. Let's detect this up here before we've done all this work. Oh. No. Yeah. No. Okay. So what I'm wondering is, do I even need to make the user list out the impl params every time? Because this will require that they check every param. This will require that they pass every param. But in some cases, I really don't care what the impl params are. No, I kind of always do. It just doesn't mean that I'm creating a new ability. There's no work to do because the params speak, yeah, they speak for themselves. But you should still, yeah. The place that I use the impl params is when evaluating an impl, so that's fine. So I could almost take in like like a flag here, like is this in the context where we need the impl params? But I think I'm just gonna leave it as is because I'm not fully understanding the ramifications of that yet. And I am gonna do this check a lot earlier because we shouldn't call specialize ability if we don't need to specialize it. Here we're detecting one case that means we don't need to specialize it. Yeah, we should do this before we clone the parameters. Not that performance really matters once we have errors. Yeah, if it's impl only, let me check what I do. So when we're actually doing an implementation, there's an ability expression somewhere. Okay, I walk the impl params and I make sure that they're passed. Because I need to actually do stuff with them. So I don't think I really care that they're mentioned in contexts other than these. Now they would control, yeah. In those cases, the ability ID is just not enough to tell you the type that like the functions are going to return. You always need to resolve to an implementation. But like here, like this also goes through eval ability expr. So yeah, I could be defining an ability. Yeah. It's kind of the same case. It's not if it has no arguments. It's if it. Okay. So I declare iterator based on the name. This is the very first time I see it. Okay, so now I have an ID for what is iterator. And that ability doesn't take impl params. Which is a problem. So look, if I fix it this way, then the ability is not going to know about its impl params, and then this is going to complain because it's going to say, sorry, this is going to complain. No, iterate, iterator, either of them. They're going to say it doesn't. That thing doesn't even take. It doesn't take any arguments, impl or otherwise. Find or eval. And this is eval ability. plain. Parsability. What is a parsability? It has its params on it. Oh. Okay. And then for each param, it does go through the params. And it pushes them all. It says if it's concrete or generic. Findability or declare. Oh, okay. If we don't find it. Do I log recursing and depending ability? Where does this come from? Oh. Oh, they're not empty. Right, of course. Do I even call you for a deafen? No. Oh, so it's only when the expression appears. This doesn't call, it gets parsability. Parsability, which is different than the expert because, oh yeah, right, the expert does the equal signs. So yeah, the arguments versus the params. Okay, I'm getting this straight again. So I'm in the wrong place. Well, if I'm looking at this code, then I'm in the wrong place with this. So this is not an ability expression. This is just the definition. It looks the same. Obviously, they should have like a mirror image of each other. This is an ability expression. So this is the one where okay. I find it. Good. If there are no arguments, oh, and it continues, and then, yeah, it's going to specialize on nothing. So, but if the ability we're talking about, yeah, because we're going to look at this later. So this function's job is just to make sure there's an ability that has applied the non-impl parameters to it. We don't have to do the right things with the impl parameters. That's going to be handled by the thing that's actually calling us to handle this whole deal. So I think this fix actually does work. But where did arguments go? I think this is backwards somehow. I want to write it this way. If impl only, and then I'll fix it. Then assert. No. Right. I was just in the wrong world. So what I'm saying here is that if you pass no arguments, then I'm just going to return you the root ability. I don't think that's right. What I should do instead is say if the ability doesn't take any parameters. So because what this would do is this would allow me to just not pass the things it needs. And it'll just return the generic version. The intent of this check is this. And we can make sure we test that. Keep it around just in case. All right. If there are no parameters, so what I could rewrite this as, it's not the case that there are any ability params. So non-impl params, which is, are there any non-impl params? And then impl only. Oh, sorry, not impl only. It's no ability side params. If no ability side parameters or no parameters, then no work is needed. Any? Yes. And we try that. And all right, so this is going to become a little bit of a NeoVim stream now. So I wrote this command. I'm a total beginner when it comes to this stuff. I have a little bit of a plugin here where I have a file type plugin. I do some K1 specific stuff. I call start on the LSP. I point it at the LSP, which is just like my cargo debug build of the LSP binary of this Rust project. And it all works, but restarting it's a pain because I want to recompile the compiler and then restart the thing. So I did this reload command, which rebuilds the LSP, and then lists all the clients from my language, detaches them all because you need to do this to clear diagnostics, stops them, and then calls the start, which just calls vim.lsp.start. And the end result is sometimes that after it blocks, it works. So we're in a different place now. List of I64 l.iter. list I64 doesn't implement ability iterable. All right, so we got past our other error, and we got to yeah. So it's happy that list iterator is an iterator, but now we have ability iterable. Which we implement for list event. And then it says list of I64 doesn't implement ability iterable. New list iterator. Shouldn't it? Doesn't that need to be a pointer? No, no. Yeah, that's fine. This thing just needs a pointer to itself. So list iterable for I doesn't implement iterator, but for int it does. For uint it doesn't. For int it does. And we implement it for list event. Ability iterable. So I think we have the same problem again. Does not implement ability iterable. What those empty parens means, you know, there are no parameters on it. But I think it's probably like printing out a specialization of it. I think I'll take a 5-minute break here and then be back, which you won't know because I'll pause the recording. Okay, so I've got a cookie and I have instrumented the code a bit. So this message type does not implement ability iterable actually can be printed from 3 places. And it's all inside this resolvability call function where first I say, I try to resolve concrete ability given this ability ID, and then having inferred, solved all the parameters that are being used. So it could be here. It could be that once I have that, I say, hey, does it implement the thing? When I go to look up an implementation for that, not just the parent ability, because when I resolve the function call by name, so when I see .iter, I find iterator, the grandparent, just iterator itself. And then I say, hey, it's iterator of whatever, the arguments, and I use the call context to figure out the arguments. And then that's what this is, where, hey, oh, we're actually talking about iterator where impl is int, right? Although in this case, it's impl side, it wouldn't matter. We don't try to solve those, but we would try to solve the ability side parameters. And once we know, hey, oh, we're actually talking about this version of iterator, then we try to find an implementation for it. And then the very last one is gosh, if the ability doesn't even contain the function, which I think it actually has to, because we resolved by name anyway. So this should be an ICE, actually. So in this case, I want to do unreachable. We resolved by name, so the function is missing by name, then like we shouldn't even look up by name because we did the resolution. Once we do that initial resolution, we should use the function index in the ability already. So actually by the time this is all the solution crap, but yeah, so I actually already know the function, the parent function. So we can add like a no commit here, no commit, say pass the ability function index, so we don't have to look it up by name a second time. And we have a bug. Okay, and now we're just going to see if it prints 1, 2, or 3. 1. List I64 doesn't implement ability iterable. Resolve concrete ability. Okay. So if the kind is generic, then we need to okay. We look for specializations. So here's the thing. This kind was me saying, does it take parameters? But I think it's going to be considered generic even when it takes only. So oddly enough, I've tested all this with, I think, more complicated abilities, but none of them cover the case where there are only impl parameters, and that's all we're running into. So if I go into ability generic, look, I did this guy, add, with a customizable right-hand side that has to implement to string and a customizable output. So this lets me, and I'm doing like a generic add on points where you can add a point to a point and you can also add an int to a point by specifying, hey, when I implement add, here's my right-hand side and here's what I want to output. So that's working, and even from and to are working. But yeah, so we have this bug where this is considered generic, but it really shouldn't be because there's no specialization need to be done. And since I just made that thing a no-op, the equivalent change here, or not here, but in where I create the kinds, is to just say it's concrete. And I could actually go further. Instead of checking that it has no non-ability params, what I could do is just check the kind, because that's what the kind should mean. So let's do that in eval ability the declaration that kind. See, so I'm saying if it's params, but where are my impl params? What? Has ability side params. Ooh, okay. I want to do the efficient thing and just track it, but it's also like with a mutable bool, but it's also mutable state and you know, potential for bugs. So let's just do. It's gonna be so fast. Sorry. Any p, and we're gonna remove the double nation and we're gonna say p dot is ability. Copilot. Yep, that's the one. And that reads much better. Any parameters that are ability side kind equal if has ability side params, otherwise it's concrete from the beginning. And now we're going to go to eval ability expert with our special case here. And instead of saying no ability side params, let's just say it's, and then we're even going to go further with kind, because I'm tired of not having these helpers. Example typed ability kind, fun is concrete. Oh, let's do that too. It's so hard to use Copilot. Okay, is this what I want? Is this what it was doing? If it's concrete, it has none. If it's specialized, I want to say it has none. That's fine. Now let's just walk down everywhere we use this type and look for places. Oh, yeah, that works. Okay, look. Down here in specialize, I'm requiring that it's generic. So it seems really logical that before I call specialize, I would check that it is. Well, that just got a lot nicer. Let me test all my other code real quick here. Take a bite of my cookie. Okay, obviously that's great news that we didn't break everything. Iterator works. What do you know? We have no diagnostics. Wow. That was my sister. She wants to play Dead Cells. So we have 10 more minutes. But this looks like it might be a great stopping point. So obviously we started this session with a huge concession. which was that we're fixing the type to int, because what you would never want to do this, right? You would never want to have to implement list iterator or implement iterator for every type. Implement iterator for list iterator for every item type, right? What you want to do is say impl t item equal t for list iterator t, which is what we'll do next. And I actually do have the parsing set up for this. I just don't have the I didn't write it yet. What this will involve is effectively, it's I think going to be pretty simple, because effectively as soon as we see this, we're going to say, okay, this is not really an implementation. This is a blueprint for an implementation. And then when we look for implementations, we're going to look not at these first. We'll look for concrete ones. That way, if someone did implement it for int specifically, it would override. And then if we fail, we will look for any of these. We'll resolve the types to see if they actually match. And if they do, we'll actually run them and store them as a plain old ability implementation. So I think it should be pretty straightforward, even though it's the most generic thing of the whole feature set. Because all it really is a lazy implementation and then function specialization, which, we already have code for. But apart from that we started this session with that big concession, I think this was pretty great. Just for kicks, let's take a look at Rust's iterator trait. So let I ref then iterator item equal 64 equals to do, and all that, so that I could go into this. A trait for dealing with iterators. This is the main iterator trait. For more about the concept of iterators generally, please see the module level documentation. In particular, you may want to know how to implement iterator. Sorry. Okay. Must use. Must use is really neat, but doing it as a compiler directive is weird. But nice, because you can put it in all the right places. It's a lot better than in Scala. You have like a compiler warning, no value discard, which is like, hey, I never want to discard anything that isn't unit, which is kind of the same, but also not, because it's a blanket level compiler feature, and sometimes that false positives all the time on bad things. I really do like being able to annotate, hey, for this function specifically, or for this type, like, it needs to be consumed. But doing it as a directive always, even back to like the Java annotations world, like just feels like a cop-out. Like your language failed you. So you have to talk straight to the compiler. So we have next implemented exactly how we did. Pretty much a translation. We have self by star by reference, and then an option of item. Next chunk, taking a const in, and this is compile time specialized on a number n. I've never seen this before. Not all those who wonder are lost. Nice. I love including the those. This is important. next chunk and is inferred as 2. Why is it inferred? Is it defaulted? Recently added. It's inferred because we're eking it with something of length 3. I hate the bidirectional inference. I really do. Size hint. Size hint seems really important. Count. Count is cool. And count probably has a default impl. It sure does. That uses fold. I love looking through this because it's like time traveling, and it's like indirectly reading like war stories, you know? Like all of these were added at a point in time, you know, inherit overflow checks. I mean, it's just so rich with like experience and things that have happened. Not so much yet, but yeah. Okay. Last, consumes the iterator. We don't have the notion of consuming. It's really neat that you can do this, right? Instead of, you know, we could only just take it by pointer, and we wouldn't really even have a way to say that it's done at the type level. But in Rust, you just write a function that consumes the thing, when it wouldn't make sense semantically. This could be implemented without consuming. The point of consuming is to say, you shouldn't use this thing anymore afterwards, so I'm just going to make it so that you can't, which is really nice, really cool. Okay. Well, obviously we would want to implement a bunch of these, but most of them are implemented in terms of next, which I don't have default impls. Well, little detour there, but I'm not ready to commit this as a test. This isn't really finished. I want to do generic impls before I would commit this. But we found a couple of bugs related to abilities that only take an impl side parameter. So I'm pretty happy. We also got to exercise the old LSP, which brings me an immense amount of joy to use. It looks like we have 2 actually LSPs now, because every time, yeah, I get 2 errors. That's okay. Does that happen? Whoops. Oh, they're piling up. Now I'm getting 3 for every. Question is, will I keep getting 3 for every after I do a reload? Ooh, yeah, some of this thing is not right here. I get 2. And then when I jump to it, I get more. And I wasn't getting, I don't know what I had done in here, but if I start this over, oh, it's because the file moved. Yeah, okay. Well, ugh, let's just call it there then. So what we have here is we added these helpers. We added a no commit, so we've got our eprint lines. Move those. Okay, what the hell? I'll take care of it. One more thing. Am I just using usizes for this? Fine. Okay. Oh, I don't have it. Yes, I do. Oh no. I do it in 2 places? Oh. Oh shoot. If it's not a method, then I just find it by namespace. Shoot. And if it has an ability ID. Oh. I still want to do it here so that I don't do it. Wow, I've got to fix that. I don't even know what. All right. This is just going to be get ability. Find function by name. Gosh, I'm so sorry for the error thing. I totally forgot I had that broken. Okay. Let's run those tests while they run. Let's get committing again. See that it's actually code that we want to commit. Sure is. We'll commit you too. Okay. Fix abilities that take only bulk parameters. Okay, yeah, they all passed except for the one that's been failing for a while. Well, thanks for watching.